Welcome, everybody. We're going to give it just another moment as folks are logging in. Thanks for being here. Right. We have lots to get through this morning on a really popular topic, so we're going to go ahead and jump in. Welcome to today's Better Buildings webinar. A series is a chance to explore the topics, technologies, and trends that affect your organization, as well as efforts to accelerate energy efficiency. We are really glad to have you on board today for a very popular topic for us, the Heating System Balancing Act, heat pumps, and beyond. However, before we dive in, I do have a couple of housekeeping items as usual. The first is that today's webinar is recorded and will be archived on the Better Buildings Solutions Center. So after the fact, you will get an email with this recording you can share with colleagues, or if you have to step out and you miss a part. Additionally, everyone on the line today is in listen-only mode, so you're not able to unmute. However, if you have any tech issues with AV, you can use the Zoom Q&A chat function, and our team will help you out with that. And we'll be introducing another tool that you all can use to actually interact and engage with us for Q&A. Next slide. So my name is Hannah Debelius, and I am with the Department of Energy, and I have the wonderful pleasure of working with our commercial partners through the Better Buildings Initiative. And for today's agenda, next, we are going to be diving into all things heat pump and heating systems, which is great. We will have a little bit of a level set with one of our experts that I think many of you know well. We want to get to know you all and your interests through some polls, and then we have two other wonderful experts on the line who are going to be jumping into some more specifics around this. And as usual, we will also save time at the end for all of your questions. I know there's a ton on this topic, and we have a pretty good turnout today. The tool we're going to be using next is Slido. So I'm hoping you all can engage with us. And right now, open up your phone or another browser and go to slido.com. And you're going to put in the event code DOE. This is the tool we're going to use for a couple of polls at the beginning so we can learn a little bit more about our audience. And then also, this is what we're going to be using for Q&A at the end. So the whole time you're going through the webinar today, you can put in those questions and you'll have the opportunity to add questions, or you can also hit the little thumbs up and upvote questions that you see so that we can try and address the questions that are most popular and most pertinent for our audience first. I'm going to say this one more time because I want you to do it right now. Go to slido.com, enter the event code DOE. You can do this on your phone or another browser. And this is what we're going to be using for all of our Q&A today. All right, with that, we're going to go into our polls. So again, slido.com, there's also instructions in the chat, and we're going to launch our first poll. This is for you all to give us some feedback about where you are on this topic. All right, so our first poll is, have you used heat pumps for HVAC systems? So I know we have a lot of owners and operators on the line today. We just want to know, have you installed and used heat pumps in any of your properties? Most folks on the line are sometimes, which is great. That's a great place to be joining this webinar because we'd love to get your questions from your real experience, but also we are here to share a lot of information and do a lot of level setting as well. And about a third of people have not used them, but hopefully are at least thinking about it, and that's what brought you here to us today. All right, we're going to go ahead and launch the next poll, please. And again, if you're just joining us, you can go to slido.com with the event code DOE in order to participate in this. So your next poll is, what is your primary motivation to use heat pumps for HVAC systems? I know from speaking to partners across Better Buildings, there are a lot of different motivators here, and sometimes those are coming from, internal in the stakeholders you're working with. Sometimes it's about meeting external goals or just pursuing efficiency and cost savings. So maybe not surprisingly to me, a lot of saving on costs is top of the list here. And next, meeting emissions targets. Maybe those are targets that are set externally. Maybe it's something that your leadership has been pursuing. You have public goals. We certainly see folks pursuing this technology for a variety of targets. All right, and also a couple of people who are not using heat pumps yet, which we saw in the last poll too. All right, we're going to go to our next poll, please, on Slido.com. And this one is, what are the barriers to using heat pumps for your HVAC system? Hopefully we'll be able to address some of these barriers on today's call with our experts. So yeah, upfront costs. Not surprisingly, if cost savings are one of your primary motivators, then the upfront cost of this technology would certainly be a barrier and something I think we can talk more about today. And a lot of folks maybe just looking for more support and knowledge on it. Great. And if you put something else, hopefully you'll be able to drop a question into the Q&A that's on Slido.com so that our experts can address your other barriers if they're coming up for you. All right. Well, this is really helpful to me and our program and also the experts on the line today. But with that, I want to go ahead and jump into our content. So we'll switch back to the slides. We are very fortunate today to have three wonderful experts on the line. Paul Torsellini from NREL, who I know works directly with many of our partners and is a frequent flyer on our webinars. Jess Farber, who's one of our design and construction allies, is joining us from CMTA. And also Stet Stanborn, who wears a lot of hats. He comes to us from Smith Group, but also is an LBNL affiliate working with some of our partners as a technical account manager. We're going to kick things off with Paul Torsellini today. Next slide. So Paul is the principal engineer for the Commercial Buildings Research Group and has been at NREL since 1994. He just actually celebrated his 30-year anniversary at NREL. So Paul, step on up and take it away.
Okay, thanks, Hannah. Next slide. I just want to talk for a couple of minutes, just a little bit of level setting here. So, when we use the term heat pump, it's really just moving heat from one location to another. In fact, that word pump, you can almost equate it to like trying to pump water. And so the first part is you need some place for that heat to come from, usually a cooler environment. It could be the air, a body of water, the ground, and you're going to pump that heat into a high temperature, usually something like your building. Now, if you think about it, this is exactly the same as your air conditioning system, except in an air conditioning system, the cooler area is inside the building and the hotter area is outside the building. And so one of the things about heat pumps is we often talk about reversing the cycle from heating to cooling. That, in essence, what that's doing is moving the building from the high temperature to the low temperature. It's really trying to pull that heat from the air. And there was a discussion on one of the polls about efficiency. Part of the reason for that is it's harder to extract that heat the colder it gets outside. And so it's a matter of how cold is your climate and will your heat pump operate to what those design conditions are. There's definitely lots of heat pumps today that will work down to sub-zero values and more coming every day. And they fall into a number of different types. Ground source heat pumps are gaining a lot of attention again because of kind of the moderation of the ground and the temperature, and easier to extract that heat. Mini splits we see in a lot of residential and spot cooling applications in commercial, and then kind of more traditional ducted systems as well as water-based systems as well. And Stet and Jess will talk a little bit more about that. But part of this message is that it doesn't have to do it 100% of the time. And so some of what our discussion about a balancing act is, what else can I balance it with, especially if I've got an existing building? Go to the next slide. So something else I want to bring up is that this is a projection of what the utility grid of the future could look like. NREL for years has done these scenarios, and really it kind of represents a surrogate for how much renewable energy is on the grid versus how much fossil energy is on the grid. And so, when we look at this, even long term, what we see is that there's always going to be some fossil fuel on the grid somewhere at some hour of the day. And yeah, we've got some pretty big decreases in that, especially during daylight hours. especially in windy areas, at nighttime. But these scenarios don't predict 100% renewable energy. And so we have to kind of put that into balance. I'm like, what is the best pathway forward, in a large scale? So next slide. Another way to think about this is, one of the terms we use is electrification. But if you look at a gas hot water heater and a typical 40-gallon hot water heater that runs on gas, you know, takes about 1.6 units of gas to get 1 unit of hot water out. And we have to get that gas to the site, and that takes energy to move that gas. So at the end of the day, it's about 1.74 units. If I switch that gas hot water heater to an electric resistance hot water heater, it's pretty close to a 1-to-1 ratio in and out. And if I then run it through the inefficiencies of a power plant, even if I'm still using natural gas, now I've got about the same amount of natural gas consumed as just burning it with the gas hot water heater. They're very close in many situations. Now, what that doesn't allow us to do is to have some other variability in fuel types, such as using renewable energies with it. But the real message here is when I move to the heat pump down in the bottom one, that 1 unit of hot water out only needs about a third of a unit of electricity in. That then goes back up through the power system. And that clearly, even if natural gas is used, is the least impact solution. Next slide. So some things I want you to look for as you listen to Jess and Steph is that, what are you trying to achieve? Are you trying to achieve a 100% solution? And what does a 100% solution mean to you? You may find that the 80-20 rule applies, especially for existing buildings that already have gas infrastructure that can take advantage of the biggest benefits of today's technology while paving the way for future technologies coming along. And just really strive for that balanced solution with that largest benefit. And that will get projects rolling faster and more confidence in the marketplace with the equipment. One of the places that we see that always is an issue is that if you have to increase the electrical capacity, that is a common way to kill a project. I know that we're going to have some discussion about oversizing heat pumps and what that means. In the past, it was really easy just to oversize boilers. We're going to hear about why that's not necessarily a good idea with heat pumps. And then another thing is you already own a cooling system in most of these buildings. So how do you turn your cooling system into a heating system and reuse parts of the capital you already own? Next slide. Finally, if you're interested, this was done by our design and construction allies, really designed for architects and for people looking at details, looking for the details technically. But this is a guide on improving the efficiency of heating systems and looking across the board at different options, what the differences are between ground source and air source. A ton of good data in here. We're actually working on expanded content for this year as well. And if you are a designer, you might be interested in our design and construction allies, both of which Jess and Stet actively participate in. And there's a URL listed there if you're interested in that effort. Next slide. So one last thing is that we're also working with manufacturers to really push to make sure that you can buy products that you need. One that's currently going on is a rooftop challenge to create highly efficient rooftops, maximizing that heating capacity by not having much, if any, degradation of cold temperatures based on a peak rating, minimizing the peak demand of the equipment to help with the electrical infrastructure needs, which that really becomes one of the key pieces. We're currently working with manufacturers for some field testing next winter and the winter after. So, and if you want more information about that effort, there's a link for more data on that. So, and I think that might be it. So next slide. Yes, let's turn it over to Jess.
Paul, and a reminder to everybody, you can hop onto slido.com with event code DOE to submit questions anytime. We're glad to have Jess on the line. As Vice President for CMTA, Jess Farber is an innovation leader with nearly 3 decades of experience in engineering and sustainability in a range of markets. So, Jess, thanks for being here and take it away.
Thanks, Hannah. Appreciate that. Yeah, don't forget to hop onto Slido. I see there's well over 700 participants on this, so I'm sure somebody has some questions. So feel free to throw those in there as we go through this. So I'm going to transition a little bit and build upon what Paul talked about and get to more of the beyond discussion here of heat pumps. So next slide, please. So before we get into some of the technical details of heat pumps, I think what we want to talk about here is the process. And so when we talk about heat pumps, we're really getting into the root is we're trying to decarbonize or electrify and save utility, right? Those have all came up in the themes early. So how do we do that? Well, there's this 4-step process that really applies to whether it's a new building, whether it's a single existing building, whether it's a campus of buildings, the process is the process. So we have to discover what's there, understand how buildings are performing, benchmark our buildings with baseline to see how our building's performing compared to a peer network, come up with ways to reduce energy. And we do that through screening and tuning of options of how we can cut energy and reduce energy. That comes down to cost. If we think things cost too much, we need to save energy, so we're not buying so much stuff. So that's kind of comes down to that implementation of getting that done. So we got to make sure something's affordable and pragmatic so we can implement these solutions. Next slide. So we always want to define, again, every project is unique, every client's unique, but the themes tend to come around to be the same kind of goals and key drivers with maybe some variances and nuances between. But when I'm focused probably more on the existing building because that's where we see the biggest technical challenge in the market of what we're trying to do to decarbonize and electrify. So I think when we're looking at existing building stock, we really need to take an inventory of what we have to understand what the life cycle of current systems in place are, because when we think of things costing too much money, we need to really value stack that and make sure as we need to replace a rooftop unit, hey, let's put in a heat pump instead of a gas rooftop unit. And it shouldn't really cost you that much more to do those, provided you have infrastructure in place to do it. So it shouldn't be like a sticker shock completely, but think about those value stacking pieces you can do as you look to replace equipment over time. We're not trying to just flip a switch and suddenly it's all electric. We want to do this over, glide to the finish line here to get these things done by eliminating those fossil fuels over a period of time. It just takes a lot of time and work to do it, but it can be done. In existing buildings, we always deal with phasing and implementation. And this can be a cost driver as well. So we really need to be thinking about how do these systems get surgically inserted into these buildings to really minimize phasing and implementation disruption that comes along with that. So be thinking about those things. So those are huge cost drivers if you're not careful with that. We want to make sure we're not impacting program needs. These systems do typically need to go somewhere. We have to find space for them. So we want to make sure that we're thinking about the building program and what we're doing and impacting that program, whether it's a school or a lab or an office building or whatever. We need to make sure we're keeping that in mind. And then again, right sizing of building systems and programs. Like we can't say that enough. I think the cost comes into play so many times where things have become oversized not for intentional, just happens, right? So we need to be thinking about what are we doing to size these systems properly, holistically looking at the building envelope, infiltration, all kinds of other features. Just don't do a one-for-one replacement. That's generally not going to be what you need to do. Loads have dropped tremendously in commercial settings with lights and equipment. So the loads we used to see when I started in this business 30 years ago are wildly different than they are today. Lighting loads are massively different. PC loads are massively different. So don't do a one-to-one swap-o change. That's not going to get you where you need to go. Next slide. So the challenges and opportunities, I think a lot of the polls kind of reflected this. Access to capital is always an issue. There's no project I've run into that doesn't have an issue with challenging and financing. So we understand that. So the age of infrastructure is going to be an issue we need to deal with it. Nobody wants to go and throw away brand new equipment, right? So let's don't do that. Let's phase it over time and do it in a way that's smart. Again, we got to find a place to put this equipment. There are some limitations for air source technologies in some climate zones. Just check local listings about what you can do and what you can't do and where you are. Any solution should consider energy recovery. We want to be looking to reduce energy anytime we implement these strategies, reducing loads and energy will have it translate to cost. And so those are the things we have to be looking for. And what we see is over time, everybody has these aspirational goals. If you look on the orange dot slide from left to right, we have all these exciting goals and just things get in the way. We get into design, we find roadblocks, so we lose some of our features. We get into cost and estimating, and gosh, we can't do this now. And in construction, there's roadblocks, operations, and we're lucky if we can get a building done in the end. But they're being done, and there's plenty of them out there. Examples and case studies you can go to of how to make this work. Next slide. And as I said earlier, it's not a light switch. We're not trying to just go all in and do it at once. As Paul mentioned, it's if you want to look at about an 80% decarb reduction, you can probably invest half the money you thought you needed to. So there's tremendous amounts of practical solutions in that lower piece of the pie, and what you can do to start getting baby steps towards decarbonization, towards electrification with heat pump technology. So those are kind of just some things to be thinking about. And again, the value stacking is so important, back to this point where if I need to replace a rooftop or I need to replace a boiler, let's think about that before we jump off and start budgeting money for it. Let's come up with a plan to how we can do this over time. So getting a plan put in place will help you chip away at this over a period of time. Next slide. So Paul mentioned heat pumps. We use air source heat pumps a lot. We use geothermal heat pumps a lot. And every project really probably can use these in any combination that you want to do. There are some cost benefits to looking at hybrid approaches to where maybe you can marry two of those system types together to help mitigate some of the first cost premiums. We see pretty large variations in first cost for geothermal around the country. That have to be dealt with, right? We can't just blindly go into this saying we can afford to do this because we have all the money in the world. It doesn't work that way. So we do know there's some hybrid approaches that go to where you can look again, stepping towards electrification. Next slide. And Paul mentioned this as well earlier. There's nothing wrong with keeping some of your existing fossil fuels if you have them there for a period of time. So we call this that interim hybrid approach. So we have a lot of facilities where there's a lot of steam infrastructure in place. There's a lot of natural gas infrastructure in place. And those are the hardest things to undo and redo to get to full electrification with those systems, right? That's really where the technical challenge comes into. We did a study for a hospital here in Boston, and that was the biggest part of it was we have to go replace all of this infrastructure just to even think about getting low temp hot water. Over time, those technologies will improve and get better. So part of it is let's wait for technology to catch up to our problem instead of us trying to just tear this place apart and redoing it. So we need to be a little bit pragmatic about our approach to doing some of these things. So there's nothing to say we can't keep fossil fuels either to help for backup. Like if something were to fail, I have that steam and natural gas sources there to help me, or maybe we keep it there for the extreme temperature conditions to when it's, my system's carrying me most of the way, but then when it gets below 10 degrees or whatever, we have to fire those things up to help us for those really few, if you think about it, it's very few hours out of the year in most climates we are dealing with that anyway. So there's nothing wrong with that kind of hybrid thought process. And again, it's a cost thing. It really helps you mitigate costs and get you baby steps from point A to point B and over a 20-year period of time. So that's just think about that a little bit different perspective. It might help you get some things accomplished. Next slide. And so we always focus on energy reduction. I think when we're looking to electrify, energy reduction and reducing of the consumption and the equipment that's doing all of that will go a long way to helping you reduce costs. So we need to invest in strategies that help reduce costs, whether it is just typical energy saving measures, like you'd go through your building and do an ASHRAE level 1, 2, 3 audit to come up with ideas to reduce energy. Those are all steps you need to take that you're probably doing already anyway, that are important to stair step down in energy consumption. Looking at your operations, obviously, shut something off if it doesn't need to be on. They're obvious things, but they go a long way, and you'll be surprised. I'm surprised every time I go into a building of sometimes things that aren't under the control that maybe somebody thought they were. And we do that through a lot of what I call aggressive retro commissioning, really getting in down and dirty into the weeds and figuring out how these systems work and how we're going to make them, get better. So there's plenty of tools in the toolbox to go about doing this. So keep those in mind. Again, it's not just go put in heat pumps and call it a day. There's a lot of things that are available to you to tackle these problems. Next slide. So that's why we always go back to one rule remains constant. You always want to look to first reduce that demand before you jump off and do anything crazy. Next slide. which would be then you start to look to generate supply. So if you're looking to put photovoltaic panels or other renewable energy sources in your building, reduce the demand first and then buy less PV to do that, right? So that makes sense. So keep that in mind as you're doing these things as well. Next slide. A little bit of a changing gears here. I think, again, whether this is more of a campus discussion or maybe a building owner that has a portfolio scale. We have a lot of clients that have buildings all over the country, or there's maybe a higher education campus that has a lot of buildings kind of grouped together. It's really important that you understand how your buildings are performing, and really even to deeper dive than that, how your buildings are performing related to how they consume steam and natural gas. And so that's where we looked at benchmark our buildings. So then you know where the problem childs are and how you're going to go fix those. So put your time and effort into the top emitters on your campus or in your buildings to help reduce it. So don't waste your time on the far right-hand side of the scale. There may be some things you need to do there, but when you come to prioritizing what you need to do, focus your time where you can get the biggest bang for your buck. And that really helps you organize getting that data set. Next slide. And if you go all this trouble of doing all these great things and you decarbonize, you put heat pumps in and you think you're saving energy, you better be measuring and verifying that you did that. So we do this a lot on projects where we get the monthly utility bills. We track how the buildings have performed. We benchmark that against how we anticipated it to perform through energy modeling, and we check that monthly. And you need to check it monthly so that if something's gone wrong, you can fix it. You don't want to wait a year to look back at this and go, oh my gosh, this didn't give me the results I was expecting to have happen here. So it's important that you do that measurement and verification. You can typically do that with your own forces to do that from a facilities perspective. So it's important to take that step and do that so that you know that you've gotten the results that you've sold to your leadership, that you said you were going to make this happen, and boom, here it is, you made it happen. So it's good to have that data. And with that, next slide, I'll say thank you, and we're going to hold Q&A to the end. So again, load up Slido if you would, and I'll let Hannah take it from here. Thank you.
Great, thanks so much, Jess. Not only did you pitch Slido, so I don't have
Shameless
to,
plug for Slido, I apologize.
yeah. And also appreciate you including so much strategy there and prioritization. I am pleased to also say that a lot of the strategy items you pulled in are also incorporated in our emissions reduction planning framework, which we include as a resource for better buildings. Speaking of resources, some of the questions we have in Slido are about links or resources. In addition to us recording and sending out the slides and recording for this webinar, we do also have a resource sheet that'll go with that. So you'll be able to get all those links all in one place with this webinar. So with that, our final speaker today before we get into Q&A is Stet Sanborn. He's Vice President and Mechanical Discipline Leader for Smith Group's San Francisco office and leads Smith Group's National Climate Impact and Performance Analytics team. We're also very glad to have him as part of our technical account manager team for the Better Climate Challenge. So Stet, go ahead and take it away.
Awesome. Thanks, Hannah. So we can just go ahead and jump in. We can skip this intro slide, go to the next one. So I'm looking at a ton of questions in the Slido, and these are all questions that we get all the time. So this is really great. We'll try to get in and start getting responses in there. But really, we want to change, I think as Jess mentioned also, we want to change the dialogue around just randomly throwing heat pumps at projects to really making sure that we're doing so in a beneficial way. And that could come down to operational costs, utility costs, O&M, infrastructure upgrades, all sorts of things. There's a ton of barriers that we see all the time when we're talking about, especially retrofits. New buildings are a little bit easier to deal with, but retrofits tend to be the challenge that a lot of you come to us with questions about. Next slide. And I want to really focus on making sure that we're talking about beneficial heat pumpification or electrification, whatever the words that you're choosing are. We want to make sure that we're providing a benefit and we're not just doing one-for-one swaps, because a lot of the questions that I'm seeing in Slido actually are a result of doing one-for-one swaps where we're just throwing a random heat pump at the problem, and then we're wondering why the operational cost might not be so good or the coefficient of performance might not be good. So we don't want to focus on just ripping out a boiler and throwing in an equally sized heat pump. Next slide. The responses that you guys gave earlier in terms of the barriers to adoption of heat pumps are eerily similar to ones from a multi-day heat pump design workshop that I led recently. But cost of install was the #1 barrier for folks that I was working with, and it echoes a lot of what you guys said. So I'm going to go through some strategies of how to bring down both that installed cost, the operational cost, and really target the coefficient of performance that you need in order to actually achieve better ongoing utility costs compared to natural gas. Next slide. So let's get into it. So we're ready off to the race. So how do we approach the problem? Next slide. I think the thing I cannot stress enough is that the worst thing you could possibly do for your project is walk down into your boiler room, look at the size, the nameplate size and capacity of your boiler, and just pick a heat pump that matches that. I can guarantee your project will be over budget. You're likely going to run into electrical infrastructure upgrade constraints that are going to just blow your budget out of the water. And you're also going to likely end up with really poor performance. So let's talk about why in the next slide. So this is from a recent survey of almost 260 buildings that the Center for the Built Environment completed. This curve represents on the y-axis or the left side, the percent of operating hours that the boiler, existing boiler, these are all boilers, were operating compared to on the x-axis, the normalized heating load compared to the max size of the equipment. And if you click next, what we're gonna see from all those data sets, and these are real life buildings operating in the real world, is that 90% of the hours, the building was actually operating at less than 50% of that nameplate capacity on the boiler. I'm going to say that again, 90% of hours, we are operating at less than half of the design load of that boiler plant. And so those hours on the, those last few hours right at the top on the right-hand side, if you were to apply a heat pump to those hours, you're buying a pretty expensive equipment that's almost never going to run. And so this is the first barrier that we want to overcome in our project. Next slide. This is similar data pulled from another campus project that one of my colleagues, Kent Peterson at P2S, did as part of their survey work. And for them, and this is probably a more mild climate than the first data set, but 80% of hours were at less than 25% of the load. As Jess mentioned earlier, a lot of these existing buildings, it was really cheap to put in an oversized boiler. It is not cheap to put in an oversized heat pump. Next slide. And so when I start to break down some of those bin hours, all those hours on the far left, it's sitting at part load. And so one of the first strategies that you can do to reduce first cost is focus on a hybrid system. If you already have gas boilers in place, you can use those to trim out those last few hours of peak load, the worst weather outside, super cold, polar vortex, all the things that everyone tells me are the horrible things on their projects and only they see. Focus on those first few buckets of getting the heat pump to cover 80, 90% of those operating hours, and perhaps rather than installing very expensive heat pumps for only a few hours, let your system, the existing system boilers, pick up that load. Next slide. So as Jess mentioned, we want to focus on efficiency first. I see a lot of chat in Slido about, well, I don't think my building heat pump's going to work. Well, it might not be the right heat pump for your project, but I guarantee you there is a heat pump that can likely work just fine for your project. But before we throw the heat pump at it, what other efficiency measures can you deploy? Envelope upgrades are a key one in cold climates, especially focusing on infiltration and leakage. We waste a lot of energy just letting heat leave our buildings. So phasing this work as part of an envelope upgrade will also help you downsize those heat pumps. So part of that then leads into phasing of the work. We don't have to do everything all at once. But the most important thing is at the bottom, and I want to stress this a lot, is collect some data so that your engineering team can actually help do a better design. If you can give us a year's worth of hourly heating use, so throwing a little BTU meter on your boiler and running that for a year, I can guarantee you your engineering team will come up with a better solution than just throwing an oversized heat pump to your project. That's likely going to have some turn down issues and capacity challenges. Next slide. One of the resources that's in the link through the Better Climate Challenge and Better Buildings Challenge for the Solution Center, we have a decarbonizing audit guide in that resources. And it goes through a pretty exhaustive list of what kind of data could be used to help us design a better system for your project. And once you come up with all those options or the data set, then your design team can give you actually a series of options. Some of them could be full heat pump solutions, some could be hybrid. And I'll talk a little bit later about the benefits of having thermal storage into your heat pump options to overcome some of those peak loads. Next slide. So this is what one of those graphs might look like. So this represents a full year worth of hourly data. On the x-axis, you can see it from left to right, January through December. On the y-axis, we have two things shown simultaneously. The upper part that's blue, those are the hourly cooling loads, and the bottom part are the hourly heating loads. So if I just looked at this graph, I'd say, well, this is probably in a mid-mild climate with, gets awfully hot in the summer, but still has a lot of internal loads in the winter. So this could be your IT equipment. It could be a lot, and I do know this building was an office building, and so there's quite a bit of actual cooling load that still occurs in the winter time that's normally achieved through economizer, but I'm going to talk about why we might want to turn that economizer off. So in this case, we have a chiller that's already existing, and they've got a boiler that's existing. And if I was asked to heat pumpify this project, here's some of the strategies I might go through. Next slide. What I see too often is folks just rip out the boiler and throw in a heat pump. And the very scientific number of electrical arrows or electrical diagrams on the left is just showing that you're likely going to double your connected electrical load, if you just throw out your boiler and add a separate set of heat pumps just to cover your heating load. And there's a much smarter way to approach a load profile like this. And we can see that on the next slide. So this is one of those options where now I'm looking at simultaneous heating and cooling. And just mentioned this, and Paul mentioned this, is heat recovery. If instead of focusing on replacing your boiler with a heat pump, you actually, at end of life of your chiller, look at replacing your standard chiller with a heat recovery chiller. That chiller normally during cooling mode is dumping lots of heat to a cooling tower or directly outside if it's an air-cooled chiller, just dumping that heat in the environment. You're spending a lot of money to get rid of heat when at the same time you actually want to provide heat. So heat recovery chiller can do both things at once. It's a really amazing technology to use. And that whole yellow zone are hours where that simultaneous heating and cooling is giving you free heat. So all the folks that are like, oh, my heat pump's not efficient enough, I can't use a heat pump on my project, start focusing on heat recovery chiller or heat recovery heat pumps, because you're going to be getting essentially free heat off of the waste coming from your cooling side, which can offset a tremendous number of hours of heating load. And so notice the area that's left in red is really small. That might be able to be picked up with your existing boiler, a tiny little pony boiler, or in the next option, a very small heat pump. So next slide. So if you are doing a full plant replacement, it might be a great opportunity to switch from a traditional split chiller plus boiler and actually look at what we call a 4-pipe heat recovery heat pump. These are air-cooled pieces of equipment or air-heated pieces of equipment that can do both cooling, heating, and simultaneous heating and cooling at the same time. So all of those hours are covered with a single piece of equipment. This is especially important for those of you that have space constraints, first cost constraints. It's a single set of equipment that can do both cycles, and so they're running year round. And again, this is a way to focus on lower connected load on the electrical side, because you're asking one piece of equipment to do both things simultaneously. Next. And one of our just absolute favorite systems, if you ask folks on our team, especially for folks in northern climates, geothermal heat pumps are an amazing resource to ride out that extreme weather event, because the ground temperature is going to change much more slowly than the outside air temperature. You have a chance to, on an annual basis, balance your load between summertime cooling, wintertime heating. I can give you an anecdote that when I designed my parents' house more than 14 years ago now. It's an all-electric home in climate zone 7, the very northern tip of Minnesota, where nobody should actually live. So cold, so cold. It has a 3-ton ground source heat pump and rides out winter just fine. And last year, the average annual temperature up there was 12 degrees below zero through the winter months. Ground source heat pump rode through that absolutely no problem. Next slide. And it'd be remiss if anybody knows me or works with me, you know that I have an obsession with pairing heat pumps with thermal storage for a whole host of reasons. But thermal storage can show up in a lot of different ways between water phase change materials, even brick, ceramic bricks. There's a whole host of ways that we could store excess renewable energy for later use. Storage and heat pumps are just an absolute beautiful thing to marry together. Next slide. And I say that because a lot of times when we look at profiles like this or other buildings, we're bumping up against an electrical capacity issue. And folks are asking, well, how can I still decarbonize even if I don't have enough capacity to meet those short incremental peak loads? And that's where thermal storage comes into play. There was a really great question in the Slido about houses of worship. I actually did a retrofit of a housing, a worship house that was trying to do a heat pump adoption, and their loads were not at all like a commercial office building. They all peaked on Sunday morning as they tried to warm up this massive sanctuary, and they had a massive boiler to do that, and it ran for 4 hours every week. Instead, we paired a small heat pump with a large storage tank and actually used that storage volume to meet that 4-hour peak load, and then used several days to recharge the tank. And so no electrical capacity upgrade required, and rather let that tank of water do the work for that short duration load. Next. So this is an example of if you are running into an electrical service limit on your project, which typically occurs on the heating side. This particular project doesn't really have one on the cooling side because that chiller was already in place. But if on the heating side, we're running into that limit, you can see that those red lines get past that electrical limit only for a few hours. That's a beautiful place for storage to be paired with your heat pump, because all those hours that you're not crossing that green line, your heat pump is charging that tank. And then for the few hours that you go past it, the heat pump plus the tank can operate in parallel and provide that peak load. So it's a really great solution. Next slide. So when you're pairing heat pumps with thermal energy storage, you can buy a lot less heat pump and let the storage ride those peaks much more cost effectively. We had a project where the storage was cheaper than the heat pump module, so we added more storage. It also lets your heat pump run when it really wants to. Smaller connected load means less infrastructure upgrades, which means lower first cost. In addition, all those non-peak days, like think of your shoulder seasons, you've got a lot of grid flexibility. So for those of you on a time of use meter, where your power might be really expensive or you pay really high demand charges, thermal storage allows you to shift your load to match that profile, so you can save even more money. So instead of a spark gap of electricity being 3 to 5 times more expensive than gas, you can shift your load until that cost is much more on par during off hours. So storage, thermal storage plus heat pumps are perhaps the most beautiful thing that you could possibly put on your project. Next slide. So I think I'm going to hand it back to Hannah and talk a little bit about some of the other resources that are in the Better Buildings Solution Center, and look forward to all your questions.
Great. Thank you so much, Seth. I love hearing you talk about heat pumps because your enthusiasm for heat pumps, especially with thermal storage, is truly palpable. And I even learned something new this time, which is that you designed your parents' house.
I did. The downside of being an architect and a mechanical engineer is that your parents have high expectations.
I love that. I only get the text of, is this recyclable? Excellent. Well, thank you so much to Stet and Jess and Paul. I'm going to invite all of our experts to come back on. As a reminder, we will be sending out the recording, the slides, and also this additional resources sheet, which will include links that all of our folks reference. We are going to be drawing the questions from Slido, and we have almost 70 questions, which is great. We'll get through as many as we can. It is not too late to add questions or also upvote the questions that are there. So if you hit the little thumbs up, that does actually move things up the queue, and so we're more likely to be able to address those. All right, so I'm going to hop over to our Q&A. Again, slido.com with event code DOE if you want to follow along or add. The first question is one that I have heard you all talk about, but it continues to come up. So let's address it. The question is, what do you think of the studies that show heat pumps are not cost effective in cold climates? And Stet, I'm gonna go back to you because
Yeah.
you are top of mind for this for me.
So there's a lot of things. There might be heat pumps that are not cost effective in cold climates. I always try to share with folks that not all heat pumps are created equal. Not all heat pumps have been designed equally. And there's been a ton of change, even within the technology, over the last even 3 to 5 years. So if you're talking about a heat pump that was deployed a decade ago, yeah, I bet it's not running that efficient. Right now in cold climates, some of the keywords that you want to look for, if you're looking especially at air source heat pumps, you want to make sure it has inverter technology, so that the compressor is really being run to match the load profile, way more efficient. And also, and this one's really sexy, but enhanced vapor injection is EVI. You'll see a little tag in the specification. What that essentially does is adds another heat exchanger inside the heat pump, and it's doing a little secondary refrigerant cycle, and it lets the refrigerant that's in your outside condensing unit get extra cold. So if you guys have 5 layers on today and you're seeing the polar vortex that's wiping through the East Coast, today is a day that enhanced vapor injection is still providing an amazing amount of heat, even from an air source heat pump. And then as Jess mentioned, ground source heat pumps, they don't care how cold it is outside. They are pulling heat out of the ground. So it's really about matching the technology with your load profile and still focusing on efficiency. I cannot stress efficiency like enough for matching load profiles.
Yeah, I often go back to even the graphic that Stet had with the, installing a heat pump that never runs is not going to be cost effective. And so that goes back
It's very
to
expensive.
that first 25% of capacity might be really cost effective. But if you did the study based on 4 heat pumps being used in that situation, it's probably no way, would work. The other thing, and it kind of goes to the next question, a lot of this is very dependent on what your utility rates are, what your demand charges look like, what kind of time of day rates you have, where you're located and how that compares with natural gas. If you have natural gas available, I have people that tell me, oh, I don't have natural gas available and I'm going to use electric resistance. Well, that doesn't make sense compared to using a heat pump, from a cost point of view. So really study what those rates are. I've also seen a lot of analyses where the COPs don't get added in on the heating side, for the electric rate. And so in essence, they're doing the comparison with electric resistance. So make sure that analysis makes sense. And if it doesn't, ask, for a second opinion on it. The other piece on that is that, especially if you're generating renewables on site, you can almost always generate renewables on site far cheaper than buying that grid power. And if you're going to make a commitment to increase your electrical load, often paired with PV at the same time makes a lot of sense, because now you're buying you have a use for a long-term asset, that you own, both sides, the production side and the consumption. And that is another way to get that cost down, even as low as, say, 7 or 8 cents a kilowatt hour over a long time period. And that can also change the economic dynamic.
Thanks. And I think, Paul, I'm going to keep you in the hot seat since you already are sliding into the next question that we have here. It's related, which is, even though heat pumps are more efficient than gas, electricity is about 4 to 5 times more expensive for the same amount of energy versus gas in my region. Do you have ideas for overcoming this barrier?
Like I said, at 4 to 5 times, I'd ask, is that on a per BTU basis, or what does that actually mean? Because if you apply, especially for a ground source system, which have COPs in that same 4 to 5 range, now you're at cost parity operationally. If you can generate the electricity on site, you're buying your own power cheaper than you're buying it off the utility. So again, I would, there are going to be places where that is so. But I would definitely sharpen my pencil and take another look at these numbers. The other thing I've learned is that these numbers change wildly. What was so 6 months ago is not so today on both sides of the fence.
And if I can add to that, I think we've got some case studies where we've done some, as part of major renovation projects, you have a lot more flexibility in what you can deploy in terms of your features to update buildings. And so we have several buildings, school buildings, for example, that were built in the 50s that went through a total renewal. If you go back and look, they had hardly any air conditioning when we started. It was all, hot water boilers feeding to radiators or unit ventilators or whatever it was, just garbage systems that need to be thrown away. And the buildings and then converted to all geothermal HVAC with dedicated outside air, the whole 9 yards you would do in modern buildings. And the building energy dollars are a third of what it was before we started by adding all of this stuff to the building. Obviously, a major investment was made in the building in terms of renewal of that building. But again, I think every case is going to be different, and just think about it and maybe what you can deploy to help reduce those costs and energy at the same time.
And I would just add in, Hannah, that to echo Paul and Jess's points, heat pumps plus storage and on-site solar, if you have the space and footprint for it, are a really great pairing. When you're investing in solar, you're locking in your utility cost for the duration of that life of that equipment effectively. You're saying goodbye inflation, goodbye rising utility costs over time. You've locked in your cost of power. And so that gives you long-term flexibility. It gives you long-term certainty in costs for operations. And when you generate that power on site, you're giving your utility folks, your in-house facilities folks, a lot of certainty of how your buildings are going to cost long-term. For our clients, that's a huge difference. We have a campus that we were working on where their cost for heating through the winter months jumped by 3x because of a change in gas prices overnight. That kind of certainty, by doing on-site renewables, you can flatten that out. So risk and resilience is also a huge factor when playing in for it. So day one cost for on-site generation plus heat pumps will likely save you money. Long term, it gives you way more certainty over where your price point is going to sit, regardless of what craziness is happening in the world around you.
I think that's a great point, Stead, is the idea that when you buy in energy efficiency strategies and even on-site renewables, you are buying your own energy futures. And those energy futures are yours, they're guaranteed, those rate of returns are guaranteed. I did a PPA on a school 10 years ago, and they thought they were getting ripped off at 8 cents a kilowatt hour. Now the utility rate is 35 cents a kilowatt hour. And they're like,
and they're just swimming in money.
Oh, yeah.
Just like
literally. Maybe not quite, but every year that price goes up, they're just making more money. Is one way to look at it. Or they hedged a really good investment up front.
I'm hearing lots of reasons to prioritize efficiency and renewables. I'm liking that. We're going to move on to the next question here. And I believe I will maybe start with Jess on this one, which is, why are air-to-water heat pumps not more common? And Jess, if I could ask you to, for our audience, define air-to-water heat pump versus the alternative as well, that would be really helpful.
Yeah, I think Paul mentioned earlier, air-to-water heat pump. It's just think of your air conditioning system in your house. It's got an outdoor unit that has the compressor in it. And in the summertime, that's blowing hot air getting it from your house and putting it outside. So effectively, we're just flip-flopping those systems, right? So we're taking the air from outdoors and generating heat from it. So what happens with those systems is that obviously the colder it gets, the harder it is for equipment to extract the heat from that outside air. So you see a large variation in efficiency and capacity with air source heat pumps because it just swings right along with the outside air temperature. When you compare that to ground source technology or geothermal closed loop heat pumps, the ground's pretty constant in temperature. So you're always working against a pretty constant temperature to push BTUs into and pull BTUs out of. And so that's really the fundamental physics between the two of why ground source is so much more efficient than air source. And we see a lot of air source heat pumps. It really depends on where you are. There's some markets that have more than others. There really is there's a variation we see all over the United States with it. And I think Stet's point was spot on. There's when you say heat pump, it's a gajillion options. There's so many different ways to do this. So don't feel like when you say heat pump, it's not the silly little wall unit you're putting on the wall and, with a little heat, with an outdoor unit. So there are some that are much more sophisticated, and we see those. We have some schools we've designed here up in the Northeast that are using 4-pipe air source heat pump systems. We're making hot water, we're making chilled water, using the air. We have to size all this stuff the right way. This is what you have to get. So when it comes to engineering, getting it sized correctly is really paramount. Again, that's what we spend a lot of time in engineering and doing that. So does that answer the question, you think, Hannah? Okay, good.
Yeah, so Hannah, just quickly on that. When you pull apart the words, when it says air to water heat pump, the first word, air, is where the energy is extracted from on the outside of the building. The second one is what kind of fluid or air is that put into. So when it says an air to water heat pump, it's extracting the heat from the air, usually outdoor air. And in this case, it's putting it into water. So a heat pump hot water heater, by definition, would be air to water. And there's actually a very common type. So you can buy these little units that sit, outside, say, your house. They are air to water heat pumps. They will generate lots of hot water from cold air, and then transfer that heat into a storage tank in your building for when you take a shower, or use it for some other heating use. The beauty of water is most of the engineers, when you talk about water, they love water because it's easy to control, it's easy to move. You get very, very good temperature control out of it. And so the idea is that, and as Jess just mentioned, you move towards putting pipes in buildings that carry hot water and cold water that then go to different rooms to provide heating and/or cooling as it's needed. The other advantage of that is then all the refrigerant is contained in a central, usually outdoor unit.
So the only limitations, or I guess limitations that we see, it's obviously easy. I say easy, tongue in cheek. It's easy to deploy that technology in new construction because you can control every single variable you're dealing with the building. So when you're working with existing buildings, you're going to be, depending on what infrastructure you're trying to connect to, you'll be limited to what an air to water heat pump can do in terms of hot water temperature production, depending on the style of heat pump you buy. So there are some limitations in today's market with some of those. You can still accomplish it. Again, you can get most of the way there by doing that. So just think about, how many buildings you have to have air-cooled chillers sitting outside that cool the building. Well, just like Paul mentioned, it's the same thing. You just turn it in reverse and it makes hot water. So it's the same, the equipment's the same. It just has to be sized and operate a little bit different.
And Hannah, I know that we're closing up, but I have to put a shout out for the decarb audit scope of work that came out of Better Buildings Solution Center. It actually goes in and has a really detailed process that you can show on how to get an auditor to come into your building and do a wintertime stress test on your heating system to essentially find that sweet spot of how low you can go with that water temperature and have your building still meet its heating load. The lower you can go on that supply water, you might be able to double the efficiency of the heat pump in cold climates for its performance. If you can get down into that 130, 140 range, so many more options. So doing that investigation work on your building is critical to hitting those efficiencies that you really want. And the guide that we can provide a link for actually has a step-by-step procedure that you can share with your facilities folks.
Don't let the tail wag the dog when you do that, because what you're going to find is one room at the far end of the building that's always hot or always cold. So we set our system to make sure that that room is satisfied. We'll go fix that problem instead of the central plant. So we see that all the time too. So that's something to think about when you do. That's a great suggestion, Steph, do that audit. So
I love how you all, in fact, I barely even need to conclude because you all were able to wrap up that discussion together, which I really appreciate. And the resource that Stet references is included in our resource document that we linked and also will be sent out with the slides and recording for this webinar. A huge thank you again to all of our experts on the line today. This is a popular topic for a reason, and I really appreciate all your expertise and also enthusiasm and honestly professorial skills that come out and explain even the basic concepts, which are super helpful to our audience. So A couple of reminders programmatically. First is that we do invite you all to join us this spring for the Better Buildings, Better Plants Summit. It'll be here in Washington, D.C., April 30th through May 2nd. Registration is open right now. It's a great opportunity to engage with peers and interactive sessions and meet folks that are having the same barriers and also find the same solutions that you might be able to use in your portfolio. So with that, thank you again. Thank you again to our panelists. It's wonderful to have your time and your expertise today. You all can reach out to our panelists if you have other questions. I know we didn't get to about 60 of them today. Or check out the Better Building Solutions Center so that you can search for specific case studies and other great resources. And of course, follow us on all the socials. You all will get an email when this recording and other resources are ready to be viewed. I hope you share it widely and have a wonderful rest of your day.